Okay, last slide we said strength is the ability to produce force. What is force? If we're looking at Newton's second law, it basically states that the rate of change in velocity is proportional to a force acting on a body. The body is the mass. So what is that? Force equals mass times acceleration. What does that mean? How do we accomplish this? Realistically, there are three different ways to input force using mass and acceleration. And if we look at that simple definition, force equals mass times acceleration, we actually see the three different sports that are actually involved in weightlifting. So we have our force, that's like I just said, mass times acceleration. If we have a really, really big mass, the acceleration is going to be really, really small. That's a really, really small a. This is the sport of powerlifting. We're trying to move as much weight as possible. It's really, really slow. Squat, deadlift, bench, sport of powerlifting. What happens if we flip the M and the A? So let's say this is 135 pounds at 1 meter a second. I'm not worried about the units right now, but just for simple mathematics, the force is 135. 135 times 1. What if we switch the M and the A? Now we're lifting 1 pound at 135, and our acceleration is 135. Well, 1 times 135, this is a large A, small m, we're still at 135. So the force is the exact same. This is an example more like Olympic lifting. Snatch, clean, where you're still trying to lift as much weight as possible. That's the whole purpose, but the speed of the movement has to be a lot faster. Finally, we're going to have, these are medium A's, medium M's. So this would be more the sport of bodybuilding, where you have a moderate mass, a moderate acceleration. That's the sport of bodybuilding. How does this apply to strength and conditioning? Why is it important? Obviously, yes, all these forces are equal, but they're going to impact the body in a different way. One, obviously, bodybuilding, muscles are going to hypertrophy, you're going to get bigger. This one's probably more neural, you're getting the motor units to fire at a faster rate. So what do we use? When do we use it? We're going to get into this a little later, especially near the end of the year, periodization and things like that. But start looking at the force velocity curve. What is our first force velocity curve? Tell us. If we remember, if this is velocity, this is force. High forces, slow velocity, that's kind of up here. And we're going something like this. This is our powerlifting. This is sprinting plyometrics. This is our Olympic lifting. There's a place and time for everything. If you actually look on Strength Coach Twitter, I know social media, everybody loves their social media. Everybody says they're surfing the curve. So this is our curve. Surfing the curve basically means we're doing something in all these regions. But yet there's a big war on, should we 1 rep max squat? Half the strength coaches seem to think this is the most important aspect. This might be a little more old school. Half strength and conditioning coaches think, never squat, let's just sprint all the time. You need to do both. Doing the plyometrics and the sprinting, and we'll go over this later in the semester, it will have an impact on maximum force production. It's going to have a bigger impact down here, but it will impact maximum force production. Or the lift and heavy weight. Lift and heavy weight, yes, it's going to have a direct impact on the amount of weight you can lift, but it will also impact velocity. Doing a little bit of everything. Like I said, later in the semester we will talk about periodization. It should make a little more sense then, but we are talking biomechanics, physics, so force equals mass times acceleration.